Yesterday we talked about differential equations and verifying solutions. So like we would have a differential equation and a function, we would take the derivative and plug it in and see if it worked. So that was some of the stuff we were doing. Sometimes we might just want to solve a differential equation. Actually, a lot of times we want to solve a differential equation. This is number 42 from your book. I think you have homework assignment, very similar type questions. So we're going to use integration to find a general solution to this differential equation. So we have dy dx equals 10x to the fourth minus 2x cubed. So to solve this, what we want to do is get everything with the y's on one side and everything with the x's on the other side. It's super easy in this problem. All we're going to do is multiply both sides by dx. So we get dy equals 10x to the fourth minus 2x cubed, technically that's all in parentheses, times dx. And now what we're going to do is take the antiderivative. We're going to integrate both sides. So the antiderivative of dy is y. Now technically this is y plus c, so we're going to have a c on this side and we're going to have a c on the other side, which we can just kind of combine together. So that's what we're going to do. But technically there is a c on this side. The antiderivative of 10x to the fourth, well, that has to be x to the fifth, and I think 2 will do it. And then minus, this needs to be x to the fourth, so I think 1/2. Yep. And then the plus c. And that's it. This is a general solution. Now, if they gave us a little bit more information, like if it said that it has to go through this point or whatever, we could plug in the point and solve for C. But we are not doing that in this question. They didn't ask for it. Now, going back up here, that was a pretty easy equation to solve. Solving differential equations analytically can be really, really hard when you get into like real world situations with these, which you'll encounter a lot in engineering. Sometimes they're actually impossible to do analytically. But we can use something called a slope field, and that can help us learn a lot about the solution. So a slope field or a directional field, it shows the direction of the slope at various points of the function. So it gives the general shape of all the different solutions. So yesterday when we looked at Desmos and how we had animated the C and it was showing us all the family of functions, a slope field does a similar thing, but not a moving picture. So let me explain how this works. We want to sketch a slope field for the differential equation y prime equals x minus y. Or another way we could write that is dy dx equals x minus y. Okay, so we know that this is the differential equation, and we want to know what would all the possible solutions look like to this. So what I'm going to do is I'm going to set up a table, x, y, and dy dx, just since we have to evaluate at several different points. Okay. And then I'm going to do a coordinate plane, because we need that. So first they asked us to evaluate, let me finish out my coordinate plane real quick. Okay, they want us to evaluate at -1, 1. Okay. So if x is -1 and y is -1, we plug that into dy dx, -1 minus 1, and we get -2. So what this means is at the point -1, 1, right there, the slope is -2. So what we do is we draw just a little line kind of showing that. Now we are also supposed to check at 0, 1. So if you plug in 0 minus 1 into this, you get -1. So that means at the point 0, 1, the slope is -1. We're just going to draw on a little line to kind of demonstrate that. We're also going to check at 1, 1. So we plug in 1 minus 1, which is 0. So that means at the point 1, 1, the slope is 0. Okay. We could keep doing this. Like what happens at 2, 1? I don't know. At 2, 1, if you plug in 2 minus 1, you get 1. So at the point 2, 1, our slope is 1. Okay. So what this does is it kind of shows us the general direction that our function is going to go. Now, slope fields are really tedious to do by hand because you have to plug in each individual point. Like if you want to know what's happening at the point 1, 2, you would have to plug it in. 1, 2, you plug it in there, you get a slope of -1. Okay, so here it has a slope of -1. So there are some things, this Desmos.com, I'm going to put this link right after the videos so that you can check it out. This will do these slope fields. Here it is. Okay, now the link automatically takes you to this function, 2x over y, which is not the function that we have. Our function was x minus y, right? So we'll just delete this. So x minus y. Oh, I deleted the equal sign. That's a problem. There it is. There's our slope field. Okay, so you can see we put in like a few points. Remember we said at -1, 1. We looked at that point. We also did at 0, 1, and we put in our little slope field, and we also looked over here at 1, 1. Okay, so we only put in these 4 little lines into our graphs. So you can see what's going to happen if we have all of them. So what this means is we can see what the function would look like. So if we know, for example, that the function goes through this point right here, we can kind of sketch the graph. It's going to kind of go up like this, follow the slope lines up like this, and then it's going to come here, and then the slopes start turning, and it's going to head that direction. Okay, this is supposed to be a movable point. It's not moving. Anyway, let's say the point went through here. Okay, right here, you can kind of see, well, the function would go up. Oops. Function would kind of go up like that. Oh my word, I really don't mean to be moving this around. Whatever. Okay, it's going to come down and then loop back. There we go. That's what I meant to do. Okay, so this gives you a picture of what's happening. This is a great tool. I encourage you to use this link to kind of see things. The disadvantage of it is whoever programmed this slope field only did it from -10 to 10 and -10 to 10. So if you are wanting to look at a point outside of that, this is not programmed to do that. I'm also going to include a couple other links to videos about slope fields so you can see another one. And we'll see a couple more examples in our next clip.